Assalamu alaikum. Today we will continue with chapter 7 about mechanical energy. Before we start, please prepare your stuff and follow these instructions. At the end of this video, you will be able to recognize that potential energy can be either gravitational or elastic, calculate gravitational potential energy, and establish a relationship between gravitational potential energy, mass, and height. We learned before that energy is the ability to do work. When a body possesses more energy, it can do more work, and its SI unit is joules. Energy could be potential or kinetic. Potential energy of a body is the stored energy in this body. This stored energy is based on the position, arrangement, or state of the body, like the red load here in this figure. The load possesses potential energy. This load has the potential to do work. For example, if we cut the rope holding the load, the stored energy will be released and work will be done. The kinetic energy of a body is the energy due to the motion of this body. When the rope is cut, the red load is moving. It possesses now kinetic energy due to its motion, and the moving load performs work and drives the wood deeper in the ground. Potential means that the energy has the ability to do something useful in the future. Are there types of potential energy? What do you think? Let's watch this video.
Potential energy. Have you seen a catapult? It has so much stored energy that it can throw stones to distant places. Also, look at this big rock on the slope. If it falls down, it can do a lot of damage. It has a lot of potential energy, which means a lot of stored energy. There are three types of potential energy. Let's look at each type. See, this stone on the top of the mountain has gravitational potential energy. This is also called potential energy of an object due to its position. Now look at this. This is due to stored energy of the spring. This is a battery. This contains chemical potential energy. It can light a bulb.
Gravitational potential energy. Gravitational potential energy of an object is the energy stored in this object due to its position at a certain height against the force of gravity working to pull it down. For example, the elephant, the boy, the piano, and the ball possess gravitational potential energy as the result of the vertical position or height. The energy is stored as the result of the gravitational attraction of the earth on these objects that we see. Let's watch this video to understand more about gravitational potential energy.
Energy all around us. Another type of potential energy is gravitational potential energy. It's very easy to give an object gravitational potential energy. You quite simply lift it up.
Any object that moves upwards gains gravitational potential energy. You can gain it climbing upstairs or standing on top of a mountain. If you really want to gain a lot of gravitational potential energy, you need to go up in a plane. The higher you are off the ground, the more gravitational potential energy you have. Fairground rides are excellent places to gain gravitational potential energy. However, you need to be prepared to lose it quite quickly as well.
Elastic potential energy. Elastic potential energy is the energy stored in objects that can be stretched or compressed. For example, we have the spring, wrapped bands in braces, slingshot, And trampoline. The more an object can be stretched or compressed, the more elastic potential energy it has. Please open your booklet on worksheet 11. The diagram below shows two identical balls A and B placed at two different heights, h1 and h2. What is the controlled variable in this experiment? Very good, it is the mass of the ball, since mass of ball A and B is equal to 50 grams. What is the manipulated variable? Very good, it is the height of the ball from ground. Let's try solving the exercises. If balls A and B are released freely, they fall and work is produced. Give the name of the force that produces work. What do you think? The name of the force is the weight or gravitational force. Excellent. Since the ground attracts both balls. Calculate this force. To calculate it, we should start with the formula. Weight equal mass multiplied with the gravity. Of course, the mass should be converted into kilograms. So, mass equal 50 grams divided by 1000 will be 0.5 kilograms. And weight equal mass multiplied with the gravity will be equal to 5 Newton. Calculate the work produced by this force in case of ball A and ball B. To calculate the work, we start with the formula. Weight will be equal to the force done multiplied with the distance. So here the force is weight. So weight multiplied with the height, which is the distance. So work done by A will be equal to force of weight multiplied with the distance, which is 5 meters, so will be equal to 2.5 joules. While that of B, it will be force multiplied with the distance of B, which is 3 meters here, so the work done will be 1.5 joules. Before falling, the two balls have a type of energy called potential energy, which is stored. Indicate the ball which has the greater amount of potential energy. Explain why. If we notice here, the work done by ball A is equal to 2.5 joules, which is greater than that done by the ball B, which is 1.5 joules. So, as a result, we can conclude that ball A has more stored energy than ball B. Because of that, it did more work than ball B. So, the work done by ball A, 2.5 joule, is greater than the work done by ball B. So, ball A has a greater amount of gravitational potential energy. Indicate the factor that affects the potential energy. What is the factor affecting potential energy here? It is at the height. Establish the relationship between this factor and the potential. We noticed here, when the work done is greater, the gravitational potential is greater. Work increases with the increase of height. So, as a result, as the height of the ball from ground increases, the gravitational potential energy increases. Height is directly proportional to gravitational potential energy. Observe the diagram below showing two other balls, A and B, of different masses and placed at the same height. Now, what is the controlled variable in this case? It is at the height of the ball from ground. What about the manipulated? What do you think? For sure here, the manipulated variable is the mass of the ball, since we have different masses of the ball. Let's start solving. If the two balls are released, they fall down. Give the name and calculate the force exerted on each ball in this case. Here, the ground or earth attracts the two poles by the gravitational force or weight. So, the force exerted on each pole in this case is the gravitational force weight. To calculate it, we should start with the formula. Weight equal mass multiplied with the gravity. For sure, the mass should be converted to kilogram by dividing it on 1000. So, starting with A, the weight of A will be equal to 1 Newton, while that of B will be equal to 0.5 Newton. Calculate the work done by each pole. For sure, let's start with the formula. Work will be equal to the force done multiplied with the distance or height. Here, work will be equal to force, which is weight, multiplied with 5 meters. So for A, the work done by A will be 5 joules, while that of B will be 2.5 joules. Indicate the pole which had the greater amount of gravitational potential energy. Explain. The work done by A is 5 joule, while that of B is 2.5 joule. The more the work done, the more the potential energy. For that, pole A has a greater amount of gravitational potential energy, since the work done by A, 5 joule, is greater than that done by B, which is 2.5 joules. Indicate the factors that affect the potential energy. Here, the factor affecting the potential energy is the mass of the pole. Establish the relationship between the factor and the potential energy. We noted that when the mass of the pole increased, the work done increased. For that, potential energy increased. So, as a result, as the mass of the object increases, the gravitational potential energy increases. Mass is directly proportional to gravitational potential energy. Formula and unit of gravitational potential energy. Gravitational potential energy equal to weight multiplied with height. Weight will be in Newton, height in meters, and gravitational potential energy will be in joule. Weight will be equal to mass multiplied with gravity. For sure, mass is always in kilogram. Gravity is equal to Newton per kilogram. Don't forget, using the pyramids of gravitational potential energy, we can calculate any missing factor if we have the other factors. So, gravitational potential energy equal to weight multiplied with height equal to mass multiplied with gravity multiplied with height. Also, the mass is equal to gravitational potential energy divided by gravity multiplied with height, and also the height will be equal to gravitational potential energy over mass multiplied with the gravity. Note that the kinetic energy is determined with respect to a reference. This will be seen in the exercises. Application. Please open your book on page 80, number 9. The athlete of figure 12 raises the load and his muscle do a work of 4000 joule. Is the load storing energy? What is the type of this energy? What do you think? For sure, the load is storing gravitational potential energy due to its height above the ground. By how much does the potential energy of this load increases? Here, the work done by the muscles of the athlete are transformed into potential energy. In the load, the potential energy of the load is increased by the work done of the athlete, which is 4000 joules. Let's sum up. Potential energy or stored energy, it's divided into two types: gravitational potential energy and elastic potential energy. The gravitational potential energy is the energy stored in an object due to its position, height. Gravitational potential energy is equal to mass multiplied with the gravity multiplied with height. When the height increases, gravitational potential energy increases. When mass increases, gravitational potential energy increases. Elastic potential energy, it is the energy stored in an object that can be stretched or compressed. Gravitational potential energy equal to weight multiplied with height equal to mass multiplied with gravity multiplied with height. Gravitational potential energy is in joules, mass in kilogram, gravity Newton per kilogram, and height in meter. Please study the summary, the application exercise, and worksheet 11. Stay safe.